Hello again. This is the first video of 7 for day 2, and the first thing I want to say here is if you haven't finished with day 1 yet, don't panic. It's totally fine. I'm just trying to get ahead of things. I think having the videos out early will let you listen to lectures at your own pace, um, slow things down, rewatch the bits that are important, and that way during class time when we're all together, we can really focus on the parts that you're having trouble understanding. It seems like the most useful way to proceed. Okay, with that said, let's get started. We're going to push our way through and learn a bunch more things about cock and how definitions work and things like that. The first thing we need to do is make sure that we can compile the previous file. So there's a bunch of text in Day02. I've updated it since, say, yesterday. Today's Saturday. I updated it since Friday the 21st. So you probably want to re-download Day02 if you didn't already have it. You should, when you advance the Blue Frontier, this line should just work. If it doesn't just work, the file that you have has a bunch of text here that explains things you can do to try to fix it. There could be a number of different things that are wrong. If this works and your Emacs works from day 01, we should really be done with almost all configuration for the next, 9 weeks. I'm sorry it's such a high startup cost. If this doesn't work, okay, we need to puzzle it out, take it to the Q&A on Zulip, or read the instructions here and see what you can figure out. This should just all work. The number one way to have it not work is to change file names or put things in different directories. All your homework needs to be in the same directory. After that, there are more interesting ways for it to go wrong. Okay, with that said, the name of this file is types, and what we're going to do is define a bunch of much more interesting types, including some types that we'll be using really for the rest of the semester, and if we're frank with ourselves, for the rest of our lives. Okay, so let's start defining what are some compound types. Here's a more interesting type definition, again using something you should be familiar with, colors. So computer monitors work on the red, green, blue color model, which is not exactly the primary colors. The primary colors are red, yellow, and blue. But red, green, blue are sort of the pixels that computers can produce easily. Every little bit of your monitor is 3 very tiny LEDs, one red, one green, one blue, and they're really close to each other. And by shining different lights out of them, we can simulate a vast array of colors as they exist in the world. Not all of them, it turns out, but many of them. Uh, so here's a type that lets us talk about color. So first we define a type like we've seen. This inductive RGB just says, hey, there's 3 ways to be an RGB value. You could be red, green, or blue. Right? We're just naming one of these 3 colors in the color model. And then we say a color in this very primitive color model is one of 3 things. Either it's black. Okay, whether or not black is a color has been debated by 6th grade students for decades. Let's just call it a color. White, and then primary. And then now what happens here is this primary constructor in color takes an argument which says that, hey, if I'm a primary color, I have to have an RGB value with me, and we'll call it P. So this is, again, the usual name, colon, type format. And what we're saying here is there's 3 ways to be a color. You could be black, you could be white, or you could be primary for some P of RGB. So if we wanted to list all of the values, we would sort of be able to see them here. They're like, okay, what are the possible values? Well, red, green, and blue are the only possible values of RGB. That's what's being said here. Black, white, and primary are the constructors of color, but primary is not a value. Primary needs an argument P. Right? The constructor primary applied to the argument P for any P that's a primary, that is an RGB, is a color. So if we really wanted to list it, we could say, what are the possible things of type primary? Well, we'll use a check maybe. So there's white, there's black, there's primary red, there's primary green, and there's primary blue. These are the 5 possible values of type color. While we're at it, we can note, okay, primary is a constructor. It has a function type that says you give me an RGB, I'll give you a color back. Okay, we can define functions on these just the same. Our matches are about to get a lot more interesting. The language of patterns we can talk about in a match is about to grow. Okay, so let's define a function monochrome that says, hey, is this a monochrome, a single color? Literally, that usually means grayscale, black and white. Is this a black and white color? So monochrome says, okay, I'm a function monochrome. You give me a color C, I'll return a Boolean saying whether or not I'm black and white. So we match C, and if it's black, white, okay, that's true. Those are monochrome colors. If it's some primary color P, where P we know is going to be red or green or blue, then we're going to say false. So if a constructor takes an argument, then its patterns, you need to name the argument. So here we've used a variable p. So p is going to be a fresh name that you can only refer to here. So here's another function, isRed. IsRed takes a color and it's going to return true exactly and only when it's the primary color red. Here's a way to write that. It's got a new concept in it too. So here, rather than writing a variable, we've written a constructor name. Remember, red is a constructor of type RGB. So the way Cox interprets this is, okay, black, that's a value of type color. White is 2. Okay, primary is a constructor that takes an argument, and we're saying when it's the case that C is the constructor primary applied to the constructor red, will return true. If it's the constructor primary applied to anything else, we'll return false. This underscore means don't care. So in the file that you have, there's a long set of examples that walks through how these things evaluate. So I'll go through this one now. Is red primary green will turn into this match. This is the substitution model of evaluation. How do you evaluate a function? You substitute in the arguments. We took the body of is red and wrote it up here, where we filled in the argument for C. So that's right here. Okay, then a match, it's going to sort of, the way to think about a match in Coq is it goes top down and says, I'm going to find the first one that matches. Okay, black doesn't match. White doesn't match. Does green match this? Well, no, green and red are different. So we'll get to here, and everything matches with underscore. So we'll return false. Okay, now you can note we could have done this differently. We could have said, oh, primary P, and then done a nested match. Right? And this is the same. This is a completely equivalent to the definition is red we see above. We could also name this. We could name this other. Now, other is not a constructor of type RGB, so that'll be treated as a variable in these patterns. Just to be completely clear, I think I've said this, but to be sure, these things to the left of this thick arrow, the equals greater than, these are called patterns, and they're the things that you match against values. Right? We could have written it out. That's fine. There's something to be said for this. Right? This would also be an equivalent definition of isRed prime. Now, once you've got them all listed out, the order here doesn't matter, right? I could put blue before green. It doesn't matter that in the definition of RGB, I've put green first in the definition. You can match in whatever order you want. It's nice to have a canonical order, just like we saw how it's nice to be methodical for truth tables. And this is a theme we'll see throughout this course and for the rest of your life, that being methodical will make your job easier. Okay. In fact, in this example, to pop back up a little bit, we could put red last and it would still work because each of these does something specific. If we put this here, we'll get a warning from Coq. Pattern red is redundant in this clause. In fact, it's not a warning, it's an error. And it's saying, look, this underscore is going to match everything. You think that this pattern does something, but it doesn't do something. So if you fix it and say, oh, I see, you're right, I meant to check on red first, then Coq will say, okay, yeah, you're cool. Great definition, love it. Okay, so then this walks through how that same version evaluates. So you just have a tiny exercise here for practice with these notations. We want you to redefine as weekday from day 1, but we want it to be fewer cases than you did last time. Don't name every day. So the secret here will be using a variable or an underscore to get things exactly the way. Okay, next up we're going to start defining some more interesting concepts. I'm going to do, the next video is going to be about numbers, which is going to be a thing we're going to talk about for the rest of this course. Then after that, I'll do a video on the whiteboard showing how to evaluate programs on paper. It's a super useful skill to do it to be able to do that by hand. And then after that, we'll define some much more interesting functions and introduce recursion in the 4 videos that come after that. All right, I'm looking forward to it. Hope everyone's doing well. Talk to you soon.